Hello, before we proceed to the main subject of this project, I would like to give a brief introduction on quality control and reliability. So, quality control can be defined as a fundamental tool for evaluating natural attributes of goods and service so that it can be compared to other similar goods or services. Meanwhile, reliability can be defined as the likelihood of success, dependability, durability, quality over time, as well as ability to perform a function. So how we can evaluate process in quality control in terms of performance? First, we can use control chart, histogram, X bar and R bar chart. So this project can be defined as a quality controls and reliability for the traffic light and red light violations. As we all know, traffic light violations such as speeding or beating red lights are one of the potential causes of road accidents and casualties caused by those accidents. Therefore, the purpose of this study will help us to understand drivers, which includes cars and vans, motorcycles and lorries, behave at traffic lights and how often these vehicles run the red lights, basically in Kota Samarhan area. So the parameters for this project will include the numbers of vehicles beating the red light, speeds of the vehicles, which known as the cruising speed for the beating red lights, and the numbers of vehicles that stop during yellow lights, basically from yellow light to red. Okay, in this subchapter, I will explain the fundamentals of manual calculations for histogram. Okay, the first step is to collect data and construct a tally sheets, which you can see in our report. Okay, the step 2 is whereby we calculate the range. The formulas for these steps is the highest value minus the lowest value in the data. The third step is by creating cells by determining the cells intervals, midpoints and boundaries. Boundaries which include upper boundaries and lowest boundaries. But before we proceed to the boundaries, the first things that we have to do in step 3 is to choose the value of cells intervals, which consists of the odd numbers such as 3, 7, 5 or 9. Secondly, satisfy the rules whereby for fewer than 100 pieces of data, use 4 to 9 cells. The third point is cell boundaries consists of lower and upper boundaries, which is based on the midpoint values, which you can see here based on the formula. Okay, the final step is plot the histogram with label axis and post the values.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMAD SHAHBARRIN bin ABDUL with metric number 70524 and I am from Group B. Today I will present about the background studies of our project. Traffic light violation in Malaysia. First of all, red light violation contributes significantly to road safety threats such as accident, fatalities and injuries at signalized junction. In Malaysia, there are 342,000 accidents and 6,297 fatalities are reported by the PDRM in 2006. In 2002, traffic light violation resulted in 136 fatalities and 155 injuries in Malaysia. So, there are two types of method we use to analyze our data, which is the histogram and the control chart. First of all, the histogram is representing the frequency or the count of data using bars. Histograms are useful for analyzing reliability data such as failure rates or system lifetimes. A histogram can indicate if problems occur early on, are randomly distributed, and increase over time. For the second method we use in our project, which is the control chart. This chart consists of two components, which is the X bar chart and the R chart. X bar is the average of the data given, and the R chart is the range, which subtracting the highest number of range with the lowest number of range. This X bar and R chart provide a statistical process control tool to monitor and understand process stability. X bar chart tracks the process mean through time by plotting the mean of subgroups of measurement. R chart tracks the process variability or dispersion by plotting the range of measurement within each subgroup. Our project focuses on the study on drivers in Kota Samarhan area, specifically at the Unimas traffic light junction. The project aims to compile statistics on driving speed and red light violation running in the area. Understanding drivers' behavior and red light running frequency will be helped policymakers and transportation authorities develop targeted initiatives to avoid traffic violation. Another one, the goal is to improve road safety and effectiveness in Kota Semarang and potentially serve as a model for other locations facing similar challenges. Next, for the location of our survey, the survey site for this project is adjacent to the traffic light intersection of Unimas Junction. As you can see here, the mark X is the Google map of the server location. Next, I will explain about my part, which is the control chart manual calculation. For the X bar formula, we can see it consists of the average of the subgroup averages, average of the ith group, and number of subgroup. Meanwhile, for the R chart, we take the individual range values for the sample and average it with the number of subgroup. This is the upper control limit and the lower control limit of the X bar chart formula. As we can see here, it consists of average X double bar plus with the A we get from the factor computing formula table, and then the R bar. Meanwhile, for the lower control limit, X double bar minus A and R bar. For upper control limit and lower control limit of R chart, the formula is kind of different, which is for the upper control limit of R chart, there is D4 we get from the factors computing in the table times with the R bar. Meanwhile, for the LCL lower control limit, we take D3 times R bar. Example, which is at day 1 of motorcycle. This includes all 5 sessions, which is session 1, 2, 3 and 4. So you can see the average of motorcycle violating the red light for 5 sessions of day 1 is 71.72. Meanwhile, for the upper control limit of X bar chart of day 1 for motorcycle is 89.0877. Meanwhile, for the lower control limit, we get 53.8323. Here is the X bar chart we created by using the Excel, which consists of the X bar, we see upper control limit, LCL, lower control limit, and the center line, which is the X double bar. Moreover, for the R chart, we take day 2 for the car and van, which consists of also with 5 sessions, session 1, 2 and 3 and 4 and 5, which is the range of car and van violating the red light of 5 sessions on day 2 is 38.556. Meanwhile, for the UCL upper control limit of the R chart, UCLR is 81.5065. Meanwhile, for the LCL is 0. This is the R chart we compute into the Excel and created the R chart with the line. For the summary of my presentation, the methodology of data calculation of vehicle number beating red light at Unimas Junction applied X bar charts and R chart. The data calculations are divided into 5 examples, as you can see, is inserted into the report. Consequently, each of the data of number of vehicle and cruising speed calculated manually, and the X bar charts and R charts are created via Microsoft Excel.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and greetings to our lecturer. And first of all, I would like to introduce myself. My name is AZNURHAFIZAL bin HAMZEH, and my metric number is 72759. Okay, I am going to present about the discussion for our project. Okay, these are the topics that I'm going to discuss for my part, which is first is understanding the histograms, second, analyzing speed distribution, third, potential data limitation, fourth, common histogram patterns, and lastly, summary and conclusion. Okay, understanding the histogram. A histogram is a visual representation of data that can be used to evaluate the speed distribution of vehicles that violate red lights. It helps to identify frequency, trends, and anomalies in the data, which can then be used to assess speed-related issues and the effectiveness of traffic enforcement. The issues are the vehicle when they beat the red light, and the second one is the vehicle that stopped before the light change from amber to red. Okay, analyzing speed distribution. This part we have discussed using histograms to assess the speed distribution of vehicles that stop before the amber light turns to red and beats the red light. The shape of the histogram provides insight into the adherence to speed limits and traffic regulations. The third one, the asymmetrical and bell-shaped distribution suggests compliance, while a skewed distribution indicates higher rates of driving above or below the speed limit.
Okay, taking the example from our reports and our data, these are the data that I can show you. The data for red light beaters. This table shows the number of vehicles that beat red light for motorcycles. For example, for day one, motorcycles, for session 1, 18 motorcycle beat red light, and session 2, 10, session 3, 15, session 4, 15, session 5, 21, and followed by cars and van and lorries and bus. This data will repeat it to do for day 2 and day 3. Then we define the speed for example, for motorcycle have 18 beat red light and 18 speed of motorcycle we define. So, and for the cars and van and lorries and buses. Okay, next, the second situation which we have to identify, which is the number of vehicles stopped before the lights change from amber to red. So these are the values of vehicles from day 1 to day 3 that we have defined. How many the vehicles for motorcycles, cars and van and lorries and buses stop before the light change from amber to red. And these are the example of data for day 1 for speed of vehicle, motorcycle, cars and van, and lorries and buses. We take it 100 of speeds. As for the data are more than 200, so we take only 100 as sample of size. Next will be the frequency, cell boundaries, and tally sheet. Okay, so these are the example data of day 2, which is the vehicle are stopped before the light change from amber to red. So we have make the cell boundaries, which is this one. This one is the lower limit, and this one is the upper limit, which is to create a cell interval, the cell interval. And then this is the frequency of the vehicle or for the motorcycle, and this one is the midpoint, and this one is the tally sheet. And this cell boundaries, frequency, and midpoint is to create the histogram and repeated to cars and van, lorries and buses. Okay, next, after defining the cell boundaries, frequency, and the midpoint, we can proceed to create the histogram. So these are the following histogram for day 2, which is the vehicle stop before amber to red light. This one is for motorcycle, this one is for cars and van, and this one is for lorries and buses. In these cases, we have used the Minitab software to generate the histogram. And yeah, so let's consider an example of histogram for cars and vans. We have collected 100 samples and calculate various statistics. The mean speed is determined to be 52.16, and with a minimum speed of 25 km per hour, and the maximum speed is 78 km per hour. Upon analyzing the data, we observe that the peak of the bar in the histogram occurs at 57.5 and 52.5 km per hour. This specific interval has a frequency of 22 cars and vans, indicating that a significant number of vehicles operate around this speed of range, making it the highest frequency recorded. Okay, next, potential data limitation. However, it is crucial to recognize that uncontrollable variables such as accidents, traffic light, malfunctions, or special events can influence the observed data and potentially impact the shape of the histogram. These factors may introduce temporary deviation from the expected patterns, necessitating their consideration when interpreting the histogram results. Okay, common histogram patterns. The shape pattern of a histogram for real-world data can vary depending on the nature of the data and the underlying distribution. However, there are several common patterns that we have observed from this histogram. Data following a normal distribution forms a bell-shaped curve. Next one, skewed distribution can be either right or left and have a symmetrical shape. A bimodal distribution also, and a uniform distribution is one in which the data is evenly spread. A multimodal distribution shows more than two distinct peaks. We have also observed it. And exponential distribution has a high frequency at the left end and decrease as it moves to the right. And this various shape in histogram provide valuable insight into the underlying distribution and characteristic of the data, aiding in the interpretation and understanding of the analyzed data. Lastly, summary and conclusion. Histogram analysis is a useful tool for understanding vehicle speed, distribution, and frequency at intersection. It is reliable and consistent, but it is important to consider external variables that may influence the data. And the summary of all the results is shown in the appendices of the report. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good day. My name is MOHAMMAD YAKOP. With number 72810. I am the one who are responsible to do the control chart and will present the finding for our control chart. Okay, first of all, what is control chart? Control chart consists of two charts, which is the X bar chart and the R chart. Both charts will be used to find the average speed for vehicles, rest of speed for vehicles, and it will be used to check for variability and stability of our data. And lastly, it will be used to determine the reliability of the data that we collected for this project. Okay, here is some of the example for the control chart that have been constructed. Okay, for beating red light category, here you can see each chart will have their own UCL, which is the upper control limit, the central line, which is the average mean for the X bar chart, while for the R chart will be the average range, and then the LCL, which is the lower control limit. Okay, here is some of the examples for control chart for stopping before light changes from amber to red that had been done. Same as before, every chart have their own upper control limit, the central line, and the lower control limit. And every control chart is divided into three more categories, which is the vehicle type of category, which consists of motorcycles, car and van category, and lastly, the third category, which is the lorry and bus category. Okay, result and discussion for each control charts. Okay, data for day 1, day 2, and day 3 for red light meters for each category had been collected and summarized in table shown here. Okay, the data were analyzed and compiled in one table due to the similarity of patterns and trends shown by the data for each day in each category. Okay, based on reference for the upper control limit and lower control limit as indicators, each category or each day data does not exceed the respective upper control limit and lower control limit values in 3 days period. This can be seen in the control charts had been done in the report later. Okay, roughly this indicates and illustrates that the data that we had collected is consistent since all of the values are in control for both X bar chart and R chart. Okay, meanwhile, data for day 1, day 2, and day 3 for vehicle speeds stopping before light changes from amber to red for each category also have been collected and summarized in a table. Okay, the data also were analyzed and compiled in one table due to the similarity of pattern and trends shown by the data for each day in each category for the motorcycles, cars and van, and bus and lorries. However, the construction of subgroup for this part slightly differs since it has higher number of data collected from the previous red light meter. Same as before, by taking the upper control limit, the UCL, and the lower control limit, the LCL, as indicators, each category also shown that the values does not exceed the respective UCL and LCL values in the 3 days period. So this conclude and show that the data that we collected have a consistent result and reliable to be used. Okay, based on the result and discussion where the data are in control, there are factors that contribute to the result. The first one is the compliance with traffic regulation. In the case of vehicles meeting red lights, the control charts that had been done shows that majority of the vehicles follow the traffic regulation or the traffic laws, where most of them do not significantly exceed the speed limit or exhibit unsafe behaviors. The second one is the effective traffic management. Throughout the control chart, we can observe and see there are no values in the control chart that exceed the upper control limit and lower control limit. This implies that the traffic management system, such as the traffic lights and the road design, is functioning well. For the real situation, we can confirm that during the data collection, the traffic lights are working properly. And lastly, consistency in traffic patterns. This is one of the main reason where there are no variables that can change the patterns except for the peak hour and off hour period. This show that the traffic flow remain relatively consistent over time. It can lead to consistent data points without significant deviation that would trigger alarms or trigger anonymous or out of control value in the control charts data. Okay, in conclusion of the control charts, the data analysis is very consistent and relevant since there are no data were out of control during the construction of the control charts. For further recommendation, we can apply control charts to optimize the traffic situation and enhance safety for the road user. Okay, the final chapter, which is the conclusion for our project. In conclusion, as for the findings and the result, we can conclude that we had successfully accomplished the project's objective, where, according to the findings of the study, we can recognize a variety of patterns and insights of the traffic flow behavior. The time of day has a substantial impact on traffic patterns and consequently driving behavior. Other than that, we have utilized the quality control tools or quality control techniques, which consist of the control or tally sheet, the histogram, and the control charts. These techniques or tools are among the 7 essential tools that have been utilized in the quality control process. Okay, conclusion in terms of community. Based on the control charts, histogram analysis, we can conclude that on average, driving speeds for all 3 vehicle categories exhibit a statistical control over the period of the 3 days. The relative stability of average driving speed within each group indicates a consistent law obedience or consistent adherence to traffic signals and a reduced risk of running red lights. These findings imply that Kota Samarahan drivers, regardless of vehicle types, maintain control speed at traffic lights. Other than that, the study also suggests further optimization to uncover new driving behavior elements and propose alternatives to improve traffic safety and traffic smoothness in Kota Samarahan. That's all from our group. Thank you very much. Assalamualaikum.